Hooke's law told us about springs stretching uniformly. Now, it's not really a law, but it is useful because in engineering, we normally want to use materials whilst they still obey Hooke's law. When they stop doing that, things get a bit tricky. Let's see why. The simplest starting point is with a spring still. So let's keep going. We haven't broken it yet. As it stretches, the graph goes up in a straight line. It's linear. Actually, the graph goes through the origin, so it's proportional. If I take the load off at any point, we'll trace back down to the origin. This is a definition of elastic behavior. If a material is elastic, it returns to its original length. There is no extension after removing the load. Let's keep loading, and you'll notice that the line starts to curve. Is this graph line proportional? What do you say? It's going through the origin, but it's not linear, so it's not proportional. The results are only proportional up to this point, so let's label that point the limit of proportionality. Now, what's going to happen if we take the load off now? Put it in a sentence. Okay, remember you can hit pause. In actual fact, the graph will still trace the line back down to the origin. This is a bit surprising to many people, but it's real. So the spring is still elastic at this point. We can keep stretching and unstretching, but the spring is elastic even though it's not following a proportional graph. If we keep going though, stretch, release, stretch and release, stretch and release, and now the spring did not go back to its original length. It's not elastic anymore. So we have an elastic limit at this point. Interestingly, if I stretch the spring again, it follows exactly the same path up to that point with the same gradient. Now, if we keep going, eventually the spring will break entirely, but we're not too concerned about that. We're interested in these points here. For GCSE, focus on this graph of force against extension, the limit of proportionality, and the elastic limit. If the examiners show you this graph, force against length, just draw yourself a dashed line at the original length. And now this portion is essentially like what we saw for force extension. I'm even going to adjust the axis like so. In the real world, engineers like to stick to this linear region where it's proportional because, well, it's straight and it's nice and easy to understand and to predict. Now, engineers tend to work with wires rather than springs, but happily, we get exactly the same behavior, we get the same graphs for wires. So what you're learning here scales very well up to university level even. Now, if you want to stretch yourself, then you could look into rubber bands, or if you want to look at A-level material, look at Young modulus and stress-strain graphs. But what we covered today in this video is all you really need to look at for GCSE.